Another method for solving the linear algebra equations, directly solving the linear algebra equations, is called LU decomposition. Okay, so LU decomposition. What is LU decomposition? So to solve AX equals to B, instead of using row operations to convert the A matrix into upper triangular, then solve back substitution, which is the Gauss elimination. What we can do else is rewrite this A into LU, L times U, where the same as its own name, LU. The L is a lower triangular matrix with diagonal element of 1. Okay, and the U is a upper triangular matrix. Okay, just an upper triangular matrix, but the lower triangular matrix with diagonal element of 1. That means, the L11, L22, L33 until Ln will be 1. Okay, let's write our lower triangular first, which is 1, 1 until Ln will be 1. That will be L21. There can be L31, L32, 1, which is L33, until Ln1, Ln2, until Ln will be 1. Okay, and the upper items will be 0. Okay, 0 can be 0, 0, 0, all 0 there until 0, 0. Okay, so this is the lower triangular with the diagonal element of 1. Then the U will be upper triangular matrices, which you have U11, U22 until UNN, or you can say UN minus 1, N minus 1, UNN. There will be U12, and U1, N minus 1, U1N, until UNN. All the lower parts will be 0. So 0 until 0, 0, 0. Okay, all 0 here. So this is the LU, and the LU product will be A. Okay. Then later we will talk about how we can solve the L, how to solve the U in order to get LU equals to A. Okay. And we can use LU decomposition to solve AX equals to B, where the A can be written as LU. Then what is this form look like? Let Y equals to UX. Okay, let Y equals to UX. Then what we have? Then we have, so let Y equals to UX. That means UX equals to Y. Then LY will be equals to B. So UX equals Y is what we assume, UX equals to Y. Then since A equals to LU, then what we have here will be LU x equals to B, right? So let ux equals to y, then ly will be equals to B. Okay, it's just based on the LU decomposition definition. And how to solve? First, we need to solve y, then we can get y here. Then we solve the x, which is our goal, to solve ax equals to b to get the x. So that is our goal. But we have to solve this part first. So this part first. This part first, how we do. This is a lower triangular. In order to get the y, you will use forward substitution. Forward substitution. So basically, you need to get what is x1. After you get the x1, you get x2, x3 until to the end. Oh, sorry. You should get first the y1, y2 until to the end. After you get the y, you will try to solve ux equals to y. So this is backward substitution, the same as the second step of the Gauss elimination. Okay, backward substitution. And we have talked about the computational complexity for the backward substitution. That is n to the second, right? The order of n to the second. Then similarly, forward substitution is the same. You will have n to the second for the computational complexity. So that for this whole system, if you know what is UL and what is UU, then to solve the x, the computational complexity will be n to the second, okay? So if we know L and U, then to solve x, the computational complexity will be O n to the second. So the on the order of n to the second. But the problem is you probably couldn't know what is the L and what is the U. You have to solve it. Then the question comes to how we solve it. Okay, how we solve it. We will first introduce how the MATLAB for the command of LU decomposition. Then we will solve it analytically. Then you will see how you get the L and the U and how that incorporates into the program. Okay, so to get L and U, you need to from this A matrices because A equals to L and U for MATLAB. Okay, the L U decomposition has already been programmed into MATLAB. And what is the command? So the commands will be LU equals to LUA. So this can be, any letters you present your L and U, but this is the LU decomposition that command tell you with the matrices you are interested. Then from this command, you will know what is UL, what is UU. Then how you get Y. The Y will be equals to, the Y will be equals to L dash B. So basically you need to do that L dash B for the command to get you Y. Then after you know the Y, so this is to get, okay, percentage, which is the comment, right? So this is to get Y vector. Then after you get the Y vector, you are trying to solve x. So x will be equals to u dash y after you already know the y, okay? Then you get the final solutions. But sometimes the A matrices cannot be directly get the L and the U without the pivoting. So this is without pivoting of UA. What is pivoting? Is ensure that the element at the diagonal to be the maximum. The absolute number of the diagonal element is the maximum. But sometimes they are not always the maximum. So we need to do the pivoting. So how to do the pivoting? What you can do is, so this is without pivoting. We can also do with pivoting. That will be add one of the matrices, which is the pivoting matrices, LUP, will be equals to LUA. So the command is now changed for the LU decomposition, but you are adding one more matrices, which is the pivoting matrices. So this is the pivoting matrices, and it's usually constructed with the 1, 0 in this matrices. Basically tells you which row got swapped. Okay, you can try from your end. Then after that, if you have pivoting your system become like LU will be equals to the PA, okay? Where the P is your pivoting matrices, A is your system, so this is the pivoting. Then after that, how you solve your final solutions, that will be P, A, X will be equals to P, B, right? So everything is times by this pivoting matrices. And this PA will be equals to LU. So that leads to LU X equals to PB. Then in order to solve the UX, which is equals to Y, you need to like first, you need to have this LY is equals to PB, right? The UX is equals to, like UX is equals to Y. Then you do LY equals to PB. Let's change your page. So if with the pivoting, the LU is equals to PA, okay, with the pivoting matrices. Then in order to solve AX equals to B, to solve, you will have PAX equals to PB. And let your that leads to LUX equals to PB, since the LU equals to PA. Then let UX equals to Y. Then what we get? We get LY equals to PB. Then after you solve these equations, you can get the Y. That Y. After that, what you do next? You do the UX equals to Y. So UX equals to Y. Then you solve X. Okay. So with this command, how the MATLAB doing? The MATLAB is first you use, instead of LU, you have LU and P, which is represent the pivoting, is equals to LUA. This is the matrices of the interest. Then in order to get Y, you need to solve this equations. So y will be equals to L dash P times B. Okay, so that is in the MATLAB. Then after you get y, you should get x by solving this equation, ux equals to y. So that will be u dash y. Okay, so in the end, you can get this x, but with the pivoting, Okay.